Hi, welcome again to Chapter 9. This is Section 9.3, Part 2. And it's basically the same thing we did in the last section, except we have this new case here where we're going to be talking about the ambiguous case. Ambiguous meaning may have different answers depending on how you look at it. I call it the donkey postulate, but really it is the postulate that you learned in geometry that does not work, called the angle side-side property, which I call the donkey postulate. Okay, so basically we're going to do the same thing, except we're going to be using triangles that have the angle side-side. Alright, so basically this next slide is just showing you that we're still using the law of sines. Remember, sides are opposite of each other. Angle C is across from side C. Angle A is across from side A. And angle B is across from side B. Okay, that still holds true. And the law of sines is still true. All right, and please remember that the law of sines only works when you're given angle, angle, side, angle, side, angle, and the donkey postulate, or the angle, side, side. All right, so let me give you an example of what would look like the donkey postulate. So let's say they gave you an angle, and then they gave you a side, and then they gave you a side. Okay, so angle, side, side. And notice that we still have a set, so I can still use the law of sines because I'm given an angle and its corresponding side. All right, so let's get right down to it. Let's look at some examples. First, we need to, though, facts we need to remember. Please remember, in a triangle, the sum of its angles are always 180. I would think that you would remember that pretty easily from geometry. Only in every triangle, the angles always add up to 180. Cannot be more. Based on that information, a triangle cannot have two obtuse angles. So if your triangle has one obtuse angle, it cannot have two. Okay, we got to remember that. And this is from Algebra 2 that you'll probably remember this, the trig section. The sine of a function, okay, we're only talking about sine. The sine cannot be greater than 1, or less than negative 1. Okay, the sine of a function cannot be greater than 1 or less than negative 1. We'll go over that more in the examples. And then lastly, if the sine of an angle, so we're still talking about sine, is a positive decimal less than 1, then the angle can lie in the first or second quadrant. So what do I mean by that? Okay, let me write it out. If you get something like this, where your sine of your angle, let's say A, is 0.46. So if this number after the sine is a decimal less than 1, then your angle can be in the first or second, I don't know what's going on here, quadrant. Okay, and we'll discuss more about this in the actual example that we're going to see in a second here. All right, so let's get right down to it. Let's start with the examples. Here we are given a law of sines problem. Notice that we have an angle, a side, and a side. So this is the donkey postulate. So we do these, though, the exact same way that we've done all of our other problems. Okay, I'm going to list my angles, and I'm going to list my sides. All right, so angle A is 30 degrees. I don't know B or C. I know that little b is 16, and I know that little a is 20. All right, so notice that we have our set. If you have a set, you are good. You can use the law of sines. All right, so now let's start the problem. I'm going to start the problem down here with my a's. Sine of 30 degrees divided by 20 is equal to, the only other piece of information I know is little b. So little b is 16, and we're trying to find angle b. So sine of angle b. All right, so let's cross multiply. First, I need to get rid of this for the time being. All right, so sine of 30, let's cross multiply. Oops, pen. Cross multiply. Sine of 30 times 16. Sine of 30 degrees times 16 is equal to 20 times the sine of b. Okay, so let's get sine of b by itself. Divide by 20. 20s go away, so I'm now left with sine of angle B is equal to, we need to get an answer here on our calculator. So I'm going to open up my calculator. So sine of 30 times 16, sine of 30 times 16, and then I'm going to divide that by 20. Divide that by 20. So I get 0.4. All right, so 0.4. Okay, now, how do we find angles using our calculator? We've talked about this before. How do I get an angle using my calculator? We have to hit the second button. So second sine of 0.4, and that should give you our angle. So second sine 0.4, and let's see what it gives us. 23.57. We're going to round that up to the nearest whole number. So 23.5 rounds up to 24 degrees. All right, so angle B is 24 degrees. Now, let's notice on the previous page, all right, it says when your sine, right here, when your sine is equal to a decimal smaller than 1, our angle can be in the first or second quadrant. Well, we figured out this one is in the first. It was, did I write that down wrong? Nope, 24 degrees. All right, so 24 degrees. So our angle was 24 degrees. That's a first quadrant angle. And in order to get a second quadrant angle, you have to do 180 minus 24 degrees. And well, let's see what you get when you do that. So 180 minus 24 is equal to 156. Okay, so 156. So I'm going to write or 156 degrees. Now, let's notice what the problem is. 156 added to our angle A is 186. Can that be possible? A triangle can never have angles more than 180 degrees. So in this problem, 156 is not possible. Okay? So let's go down to now, once we find this, all right, now we should be able to find the rest of our angles. We know 30 and 24. So 30 plus 24 is 54. 180 take away 54 is 180 take away 54 is how many degrees? 126. Okay, so our third angle is 126 degrees. Okay, let's get rid of all this. And lastly, now we need to find angle C. All right, so let's find angle C. Let's set up our law of sines again. So I'm still going to use my sine of 30 over 20. Sine of 30 over 20 is equal to, let's do the C now, sine of 126 over little c. Okay, let's cross multiply. 20 times sine of 126 equals sine of 30 times c. Okay, how do I get c by itself? I'm going to divide by sine of 30, divide by sine of 30. So c is equal to, on our calculator, let's get rid of everything over here, 20 times sine of 26, 20 times sine of 126 equals, divide that by sine of 30, equals 32.36, or 32. Let's just round it to one decimal place, 32.4. So going back up to here, our C is 32.4. And there is our 6 answers. It's a little bit harder. Hopefully it makes a little bit of sense. Let's do another example, and hopefully it'll become a little bit easier for you. All right, so let's look at this one. Notice it's still angle, side, side. Okay, so let's now once again list our sides. Our angles on our sides. So angle A, angle B, angle C, little a, little b, little c. So angle A is 30, little b is 16, little a is 7. All right, let's set up our first law of sines problem using our a's. Okay, notice we have our set. Sine of 30 over 7 equals sine of angle B over little b, which is 16. Cross multiply, let's do this in our head. Sine of 30 times 16 is equal to sine of b times 7. Divide by 7. Divide by 7. 7's cancel. So sine of b is equal to, let's see what this is now. All right. So sine of 30 times 16, and hit enter, and then divide by on the bottom 7, and I get an answer of 1.14. All right, so I get sine of b is equal to 1.14, and I get that right off of my calculator. Okay, now, how do I go about getting angles? Remember, you hit the second button. So second sine 1.14, and let's see what that gives us. Second sine 1.14, enter. And what do we notice? We get an error. Okay, so the calculator will give you an error right here. Now the problem is, what does that error mean? Okay, so let's go back to our steps here, and what do we notice? The sign of a function cannot be greater than 1 or less than negative 1. Can't be bigger than 1 and less than negative 1. So what did this example give us here? It said that the sine was equal to 1.14. Well, isn't that bigger than 1? This is bigger than 1. Not possible. So 0 triangles are possible. You cannot get a triangle that has one of its sides having a sign of bigger than 1. So as soon as that happens, as soon as you see one of your signs is bigger than 1, you can stop, say 0 triangles are possible. And your calculator will tell you that it gives you an error. It will tell you that there's an error there. Okay, so that's kind of a nice little problem when that happens. Okay. All right, last one, last example here. Example 3 says, let's set it up again. Everything is basically the same. So angle A, angle B, angle C, little a, little b, little c. Angle A is still 30. Little b is 16. Little a is 10. Okay, let's go ahead and set up our law of sines problem. So sine of 30 over 10, we're still going to use that, set our a's, equals sine of b over 16. Hopefully I can do the cross multiplying pretty easily here. Sine of 30 times 16 equals 10 times the sine of b. Divide both sides by 10. Divide by 10. 10's cancel. Sine of b is equal to sine of 30 times 16. Sine of 30 times 16. Oops, forgot my parenthesis. Enter, divide by 10. Enter, I get 10. That is wrong. So I forgot to divide by 10. So I'm going to do, I messed that whole thing up. So sine of 30, let's start over, times 16 divided by 10. And I get 0.8. Okay, so I'm going to go back here, 0.8. Once again, how do I find angles on the calculator? Second sine, 0.8. And that will give me my angles. So second sine, 0.8, enter. And I get 53.13. Let's just round to 1 decimal places, so 53 degrees. Now remember, when you get a sign that is smaller than 1 in decimal form, we can get a first quadrant or a second quadrant angle. We already got 53. Now we do 180 minus 53 to get the other one. So 180 minus 53 is equal to 127. 127. So those are the two possibilities. You always have to check and make sure that they work. Okay, let me get rid of this real quick. So remember, angles can only add up to 180. 30 plus 53 is 83, so that still is okay. 127 plus 30 is only 157, so it's still less than 180 degrees. As long as both of these angles are still less than 180 with the one that they gave you, you are okay. You can now have, what we say is we have 2 triangles possible. You always have to write that. If both of your angles worked, you have to write 2 triangles are possible. Then you just go along with the rest of the problem. Okay, we're going to use the 53. We're not going to use the 127. Even though the 127 works, I'm only going to make you solve one of them. Okay, So now 30 plus 53 is 83. 180 minus 83 is 97 degrees. Okay, so our other missing angle is 97. Now let's set up law of sines for little c. Okay, so our last step. Sine of 97 over little c is equal to sine of 30 over 10. Cross multiply, I get sine of 97 times 10 is equal to c times sine of 30. Divide by sine of 30 on both sides. Divide by sine of 30. C is equal to all of this on our calculator. Let's go do this on our calculator. Sine of 97, close your parentheses, times 10. Enter, divide by sine of 30. Enter. Oops, go back. I didn't hit the divide sign again. Divide by sine of 30. 30. And I get a mistake. Let's start again. I don't know what's going on with this calculator today. Sine of 97 times 10, enter, divided by sine of 30, enter. So I get 19.85. 19.85. So 19.85. And there are my three answers. Okay. So quickly, this one had 0 triangles possible because we got a sine bigger than 1. The first one, let me go back. This one only had 1 triangle possible because the 136 or 156 plus 30 was already bigger than 180. Okay, we are going to make sure that I explain this a little bit better tomorrow. This is a little bit harder to put on a video. Hopefully that makes a little bit of sense and you have a fairly decent background of this. We'll make sure we fix any mistakes, and I will see you tomorrow.